Hey, there you are. Okay. All right, let's give the rest of the people a chance to catch up. How come there's nobody there's only us? Yeah. Yeah. Okay. Many of the regulars are not here yet. I hope they didn't get spooked by the midterm or anything. The midterm was quite easy, right? I mean, it was rather easy, wasn't it? Yeah. Okay.
Yeah, I have a question about the meter.
Mm-hmm.
It's about the question like one int divided by another int, and the output should be like how many digits after the point.
But there's no point. What I mean is there is no point in an integer. Right?
Yeah.
Yeah, so there's no digits after the point because there's no point. The integer
Yeah.
data type, if you divide an integer by an integer, you only get an integer. It's not a floating point representation.
Yeah, but you assign the output to be double.
Doesn't matter. Oh, I see. Yeah, so if you take the integer and put it in a double container, yeah, there's no digits after the point, right? Because you took an integer.
So I choose it never had the DJ after the point, but I got wrong on the both question.
I'm all right. Well, I'm sure there's a confusion here because this question I've gone over the test so many times now that right. So what we'll do is let's take this offline and then just email me what you think your confusion is, right?
Okay.
And then I'll try and clarify that because yeah, maybe a few quarters ago, I might have said maybe there's a bug in the question, right? Because and most of the other students have not encountered it, so there must be some misunderstanding. Maybe the question needs to be rephrased. Maybe it's confusing a lot of students. Anyway, I mean, thanks for speaking up, right? Because now you mentioned something about this question, and you're going to email me hopefully, right? And if I get like 10 or 15 of these emails about the same question from many students over a couple of quarters, then I know that there's something wrong with the question. I need to go and fiddle with the word or something, words, or try and make it clearer. Yeah, okay. All right, just get in touch with me offline by email, and I'll.
Okay.
All right. Hey, as usual, we can start at 8:15. We don't have to start right now, so we got like 10 minutes. So feel free to talk about whatever you want. And
question here. This one. Okay, you see?
Yeah. Oh no, don't bring. You want to talk about the question here?
Oh.
Yeah, I don't know. Just let's do it by email, and then if you still have a question after that, I'll absolutely bring it up in class again, right? But I think now it's okay. Don't bring it up now, because I'm pretty sure that we'll spend like 5 minutes talking about that question, but it's probably a simple confusion all the other students didn't have. Yeah, okay, so don't. Let's just maximize our time, right, in class. Whenever we start drifting into a topic or anything, right, anything, doesn't even have to be, right, when we start drifting into something and it's not of general interest, right, if people could just chime in saying, hey, no, I don't want to know about the intricacies of the star operator in this context, right? Because I'm not even going to encounter it until CS2C, but I'm happy to wait until then, right? You should just pipe up, right? Because sometimes it's just carried away. Because there's a certain construct that is going to be so immensely useful to you, right? So immensely useful downstream, right? But you're never ever going to be using it so much in Tue May. Right? So suppose we, by chance, because of someone else raising an issue and we talk about it, and then I just got, we get immersed in it, right? And then we might spend a lot of time talking about some of the intricacies of this thing when they're not even relevant to you now. Or maybe even, it's probably a disservice to talk to you about these things, because maybe I'm basically just robbing you of the pleasure of finding out yourself, right? Because, when I go into so much detail about something, Really, I'm just digging and digging and digging and taking away all of your treasures. So I shouldn't really be doing that. So when I do that, just feel free to say, ring me in, right? Say, okay, wait, I've had enough. Let's move on to the next thing. And I'm very happy to do that, because otherwise, there's no joy in sucking the joy out of someone else. I can tell you that, right? So it's better to enjoy it on both sides. Meaning, I've had a great deal of fulfillment out of this particular thing. I've used it in so many different projects, right? And in different kinds of programming constructs too, right? So I used it. Doesn't mean I have to show you every single thing, right? And then what's the fun there? So it may take you, I don't know, maybe it'll take you several years to discover them, but who cares? Because all along you're going to be looking for what's the best I've got, right? What's the best I can be resourceful with? What is the best I can do with what I've got? Yeah, I think, and you're going to be asking that question. And as long as you keep finding the best that you're able to put together, it doesn't matter if it is the best ever, right? Because there is no best ever. Even the best people out there, they're still looking for the best ever. So there is no best ever. So if you think I want to find the best ever, yeah, it's going to be really hard. And it's probably an impossible task. So what we can say is that, what I want to be good at is not being able to find the best ever, because there are lots of librarian type brains, right? So, I mean, there are many people who you can ask, what's the algorithm for this? What is the best way to solve this problem? And they'll just read off a solution from a book, right? Or from a research paper, right? And say, oh, it was published like 4 years ago and this, and that's the way to do it. And so they're very good at it. In remembering, right? So we can absolutely get good at it also, right? I mean, we can just remembering lots and lots of things and trying to see where the things fit, but that is not the skill that a college student needs to learn, in my opinion, right? So because there are too many facts out there, and a college would be doing you a disservice if it were to take an empty container and fill it with facts and send it out. So the job of the college should be, or any teaching institution, should be to take an empty container and say, well, you know what? So what do you want? So you're empty and you want to get filled? Okay. So yeah, I can show you a couple of ways to get filled. Okay. So we show you a couple of ways. Yeah, here you can get filled through history or that, all these things, right? So different subjects and different ways of getting you filled, so that now you don't need us anymore. Right? Because otherwise you got to keep carrying us with you all your life, right? So, and then we get you to a point where you can fill yourself, then we don't have to teach you everything. And I think that is the goal of, most, all teaching institutions anyway. So if we, like now, right, nobody spoke up, right? And I was saying the same thing 4 different ways, right? So I said the same thing 4 different ways using different, and nobody spoke up saying, hey, enough already. Let's move on. Let's talk about something serious. Okay, so you got to be on the watch out, right? Because that's also a lot of, that wastes a lot of time, right? Because many times we just get presented the same information over and over again in many different guises. And then we just marvel, thinking that's something new, right? But the marvel only lasts a little while until we find out it's not something new, right? Every time we marvel at something and then lose ourselves in it for a little while, if it's shallow, we just find out, right? So it's not something new. Well, I've seen that before. So then you get really good at abstracting things out. It's factoring in mathematics, right? So you have ax plus bx, you can factor the x out. So it's, and you start looking at all these things and start factoring out what's the important thing, what's common between all of those. And then if you take out the common thing, then that's really what they all are. And then you learn to recognize patterns, and patterns are really, really powerful, right, in computer science, because most of the time patterns are what you use to build higher level constructs. And because you start off with basic control statements, if, then, else, and so on and so forth. So you can call them your Lego bricks, right? But eventually you'll get tired of building everything from single bricks. So you're going to say, well, you know what? I'm going to use this Empire State Building construct, right? Many different, I want to build the Empire State Building in 5 different places in this Lego universe, right? So, but I don't want to keep building it from scratch every time. So I'll just subcontract it out, or I'll just use a pre-built Empire State Building, right? And I'll place it in different places. And so that's a pattern. The Empire State Building, or any particular thing, is a pattern of Lego bricks that have come together in a particular form, that you can now find is generally useful, so I can use it everywhere. So you say, well, now I can also have these basic Lego bricks, but I also have these patterns or building blocks that I can use in other things. Yeah. And so that's how we get good at identifying these patterns. And once you identify patterns, what's good of patterns? Sure, patterns let you build something bigger, because you can build something bigger with patterns. And I think it's important to keep on building bigger and bigger with patterns, so you can see not to get to the top, right? So, and we always confuse ourselves saying the reason to keep growing is because we can get to the top, right? That is absolutely the wrong reason, because there is no top. You can never reach the top, right? So the reason to keep growing is to find out what it is that keeps you growing, right? Because once you find out what it is that keeps you growing, then you don't care if you reach the top or not. I just keep growing, right? And that itself is fun by itself. So and so people who are always looking for, I got to do this because I need to get an A+, because I have that end goal, I need to reach that goal, they'll they'll find that the goal has moved on. And they'll keep slogging away, right? And they're going to slog away until they die, right? So, but if you're really clever, we find out, okay, well, you can play all this in your head and say, I know that's if I follow that route, that's where I'm going to end up. I know for sure now, because I can see it playing out. So what I want is not to find that, but I really want to find out what's really cool about going in that direction. Right, then it doesn't matter. It doesn't matter if I reach there or not. I just keep going in that direction, and I can keep doing that as long as I'm alive, because that's really fun to do anyway. So, and I think that is where we're going. I don't know where we're going with all this. How did we even start talking about this? Well, look at the time. It's 8:15. As usual, as promised, I've kept the airwaves occupied for 15 minutes. So yeah, we can start talking about it. Hey, by the way, here, I'm so happy Isaiah is here. Wait, let's wait until he connects to audio, right? Because, yeah, I don't know. So apparently it is a pollen grains in the air. I don't see any pollen grains. So, and it's been the same for a long time. So, but I've been blowing my nose quite a bit, right? Yeah. Hey, Isaiah, are you connected? Anyway, Isaiah and some others who I sent email to need to get back to me. Those who did absolutely horribly on the midterm, you can get another crack at it, okay? All right. Or missed it by any chance. Like, some of you accidentally missed the midterm due to a legit reason, right? You can't say I missed the midterm because I was out partying, right? Then that's it. But if you have a legit reason and missed the midterm, you can absolutely take it again. And also, if you did, really, really badly, then say, well, okay, this time I'll do a good job. And I was actually thinking I'll just open it up completely for everyone in week 11, like I promised Elizabeth will do with our data representation quiz. Where's Elizabeth? Yeah, she's absent. Oh, there she is. Okay. Did you just join, or were you not even, because I didn't even see your, panel on screen. Hey, someone get in touch with Isaiah, because he's connecting to audio and we can't hear him, and I don't know if he can hear us. So someone send him a chat message or something. All right. Yeah, so, but then I said, yeah, let's not do another midterm for everyone, because, in week 11, because already many of you have done really well. And then, if you're 18 out of 20, what's the fun in getting to 20 out of 20?
What do you want me to send to Isaiah?
Oh, he's connected now. Thank you, Mark. Thank you. Yeah, he connected. Oh. Hey, Isaiah, you got to reply to my email, okay? So I sent you email some time ago, you and a couple of others. And I think only one person got back to me, right? You got to get back to me if I send you email. All right, please do check your email. I can't rely on Canvas to get messages to you. I told you this before, right? Because Canvas is not sending notifications, and so you got to get back to me. And if I ask you a question, please reply. Here's the thing, right? How about this, right? Because I'm putting in the effort to send you an email. If you don't reply to that email, I'm going to take one participation point away, right? Each time you have an unanswered email from me, you lose one participation point. Maybe I'll put it in the syllabus next time. All right. So yeah, please reply. Because otherwise I can't make decisions. I can't just decide that's what we're going to do, right? So let me All right. So it's actually good we started talking about some of the, I think, right, we started talking about some of the conceptual issues around abstracting things away and keeping things in a black box, creating our own type, creating our own data type. So that's what the second half of the course is about, right? So, so far, and anybody should just feel free to interrupt me, okay? If I'm not being clear, or just feel free to interrupt me at any time. I don't know why nobody's interjecting at all, okay? Mark just spoke up one time, right? And nobody else is ever speaking up. And so you guys have to be totally free, okay? Because unless you interrupt me, how are you going to interrupt someone else? How are you, someone who's, you're working with someone and they're coding away and you're just waiting for them to stop until you tell them something? No, that won't be a productive relationship, right? So you got to get comfortable enough to code side by side and keep talking. And talk about anything. What the hell? Who cares, right? The important thing is to just keep flowing, not staying. And
all right, so, I got a question. What?
Yeah, thank you,
David. I thankfully have no meetings this morning, so hence you get the full face. I was just curious.
Office, by the way.
Thank you. What topic should we be on for this week? Should we be on classes, or are we still working on?
Starting from today, we'll do classes.
Okay.
Yeah, and so that's why I said, until the midterm, we were just doing C programming. It's the same C programming, right? Now, from now on, we're going to do C++ programming, which means that we've taken the raw power of C, because, with C, you can do a lot of things, and said, no, I don't want so much power. Well, I do want so much power, but, hide a lot of it behind the screen, the man behind the curtain, right? It's there. I know I can use it, but if I see it all at one time, I'm really scared because I can't. So that is what C++ is. Yeah. So in case anyone is ever, doubtful as to, oh, C++ is not as powerful as C and things like that. Yeah. C++ was basically just introduced to keep people from being frightened by the full power, the Visvarupa, as they call it, right, of C, right? It can do anything and basically melt your computer down. But most people don't want to do that, right? Most people want to live a happy life and say, okay, well, I know I can do it, but put some walls right here. All right. If I need to open that door and go in to this wonderland, if I want to screw around with the universe, okay. So I want to stay on the side, and now hitherto you would have known that. You're probably very comfortable now, right, with saying I want an integer. I want a char. I want a double, right? Yeah. So is everybody comfortable with asking the compiler in a function, saying in this function, I'm going to be using these integers, these variables, and give me these data types? Is everybody okay with that? Yeah.
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 Okay. All right. By now, yes. By yeah. And that's why. So now, imagine that if you, at some point, said, you know what? Every time in my program, in my algorithm, every time I ask for a student's name, I'm also simultaneously asking for another string for the student's, student ID or number, right? Number. So I want a student's name and a student ID. And every time I'm processing a student, I'm processing the two together. So I have two options, right? One is I can say, give me a string and an integer. The string will store the student name, and the integer will store the student ID. Yes or no? Then anytime I want to process a student, I can process two of them together. Yeah?
Yeah.
Okay. So now, and that's what we tried to do very, very early on, even in C, before maybe Dennis and Richie and Thompson, right? Yeah, they created the struct. It's called a struct, right? A struct is a package which says these two things keep getting used all the time together. So let's throw them together and put them in a bag, so that from now on, I don't have to ask the compiler for two things. I don't have to ask the compiler, give me a string called student ID, give me a number called student. No, give me a string called student name. Give me a number called student ID. So every time I need to ask the compiler for two things, right? A string and an integer. So instead, I can tell the compiler, hey, compiler, I'm going to put the two in a bag and call that bag a student, right? And inside that bag, I'm going to have two things. I'm going to have a string, which is going to be called the name. And I'm going to have an ID, which is going to be called a number, which is going to be called an ID. Right. So inside the bag, I have the two things which I always keep asking separately. Now, anytime I ask you for a student, give me both of those things. Right. So you're basically saying, think about it, right? It is just syntactic sugar. At this point, we're touching about the first aspect of what an object is, right? This is one more very important thing, right? And we'll cover that also. And again, by the way, so here, because this is the very first class in object-oriented, in the second part of after the midterm and all, I'm just doing a conceptual overview of what an object is and some of the motivation behind it and why we need objects and so on. We're doing very little coding, but I'm hoping that starting Thursday, we will actually start coding again, right? And we will start getting volunteers one more time. Now, actually, Anwar, where's Anwar? He was here a few weeks ago, or a few classes ago, and he wanted to come on screen and code, and he's absent. So I have to get in touch with him and tell him, you're not getting a chance to code unless you're actually in class, right? Anyway, so I'm thinking, someone come up with an idea, maybe turn one of the games that we wrote into an object-oriented way of thinking about things like that, right? But all of that will, those ideas will start bubbling up in your head after we have our introductory discussion today about what objects are and what is the motivation for having objects, right? And what's the history, right? Where did they come from? Miraculously, one day, Strip said, "Oh, I'm going to turn this C into a C++." No, it's not like that. No, like all great things, the growth of C++ was actually organic, right? The seeds of C++ were already there in C, assembler. Turing machines before that, right? Because, if you can technically write a Turing machine program, even though it may be trillions and trillions of miles long, dot dash, or dot space, miles and miles, trillions and trillions of miles from here to the Andromeda galaxy, you write a Turing machine program, even that can be written in a well-structured object-oriented way, right? Because in your Turing machine instructions, you're going to have many different repeated instructions, right? Obviously. So you'll factor those things out, and you'll see scope for objects you're using, and then you can write an object-oriented program in Turing language. Basically, I'm saying you can write an object-oriented program in a binary, right? Ultimately, what it is, that's what it is, right? Everything becomes binary before the CPU executes it. And
so, what would you say is a good differentiation, sort of? What's the biggest difference between procedurally generated programs and your object-oriented programs?
Okay, so I think it is not I think it's a false distinction between procedural programs and object-oriented programs, because object-oriented programs are also procedural. Procedural basically means you're running one, stepping through it one at a time. What I think what you mean is a non-object-oriented versus object-oriented, right? Yeah. So two very important parts of object-orientedness. The first one is take things that write together, put them in a bag, and give the bag a name. That's the first important property of object. So we're saying, and that property already existed in C, right? Because C assembler, like I said, in Turing machines, right? So all you're saying is that take a struct, it's in C, a struct, and to put a lot of things in it every time, and then give the struct a name. And then you can ask the compiler, give me that struct, and you get all those things in the bag in one call, right? And so that is basically, and that struct is basically an object. So anytime you say, give me a student, that student is an object. It's a struct. A struct is an object, right? However, object-orientedness, right? So what we today refer to as OO programming, or object-oriented programming, brought along one more very, very important thing to this mix, right? Although it was already object-oriented at that point, the real power of OO programming, in my opinion, came about when this whole idea of abstraction and information hiding actually took the forefront, right? I think it was there's actually a very interesting story I read in Mac Folklores, right, about Steve Jobs visiting that time, who was this chairman of Novell and Son, or the guy who became the Google chairman at one point, Eric Schmidt. Right, Eric Schmidt was, I think, the head of Sun or Novell, Sun, right? And Steve Jobs went to Sun to pitch the idea of Objective-C, right? This was the days of C programming where no objects were there. And Steve Jobs and his Apple team came up with a version of C, which they call Objective-C, right? Which is C with object orientedness built into it, which means that they actually saw the power of hiding things away from the user. And if you think about it, that is the core of Apple mission, even today, right? Because they take a great deal of complexity and sophistication, and they basically hide it from the user. So that when you pick up an iPad or a phone, a child can interact with it using human intuitive gestures and modes. Yes, and so that it's exactly the same principle, right? When you look at a company and its mission, you can see it percolated and reflected in all its products. So Objective-C was really seeing the value of hiding things, right? Seeing the value of saying these things are irrelevant. Right? If you think about these things, you're not going to think about the bigger picture, which is really important. So let us take that away from you. And if we show you all the other nonsense, your mind, like a monkey, is going to look at everything. Right? It's very hard for you to control your mind and say, this is the only thing I need to look at. Everything else is, distraction. So what we'll do is we'll help you and say, right, well, here's the big picture. But because your mind is going to be like a monkey jumping around, we're not going to show you the whole picture. We'll only show you the thing that is really important to you. Yeah, and as programmers, as early beginning programmers anyway, when you have a struct, for example, right, and everything inside the struct is visible to you, right? And I think, especially early programmers, kids who learn to program, they just run amok, right? They just have so much power. So, and they see a lot of freedom, but no direction, right? And so I say, oh, there's all these things. Obviously, I should be able to do things with this, right? And they screw things around, and pretty soon they find themselves in a big mess. They don't know what to do, right? And so as a little grown up, they say, well, you know what? The problem really is our kids not able to look at everything and focus on one thing. So let me just hide everything, right? And show them the one thing they're supposed to focus on. Right? That idea of hiding is so valuable because it allowed the child to progress. Because if information was not hidden, the kid would never have progressed. It would have looked at all these other things and been distracted. But because all of those other distractions were carefully removed by a master, the kid was able to focus and go to the place. And then, more hiding. And so a great deal of progress was made when progress was hitherto not possible, because of distraction. So that power was always there. But I think that story, that Steve Jobs story, illustrated that beautifully, because he went to Sun and he was explaining to Eric, saying, this is the power of Objective-C. This is information hiding brings you so much. So we should all adopt it, right? And I think this is a story, it's public, right? And Eric listened to him and said, no, I don't think that's, well, it's nice as an experimental feature, for kids to play around, but no, that's not really the power of C, right? We have to deal with the real power, and that takes away a lot of power. And so he dismissed Steve Jobs, right? Steve Jobs ran away, and then Eric went and sat in his chair. And after a while, he went to the window and looked out, and Steve Jobs hadn't left the campus. He was still in the parking lot, walking around his car and fretting and fuming. And then he walked back up to Eric Schmidt's office and said, no, I can't agree that you're right? You're wrong. And here's the reason why Objective-C is better than C. And he came up with more reasons to try and convince him. So, and that's because he had seen at that point the power of hiding, right? Because people always say the real power isn't showing. Right? Show everything you've got, right? Scare the shit out of them. But the real power is not showing everything, showing only the thing that is needed and hiding everything else. And so, because you can see the power of hiding, because if you hide everything else, you can make progress. And I think that is the power of object-oriented programming itself, because object-oriented programming says, okay, when you design an object, right? When you design a group, a bag like that, right? That is the first step. Now you've got a way in which that's really syntactic sugar, right? So far, we're only syntactic sugar at this point. Syntactic sugar meaning, you can do everything, but really you haven't taken any power away, and it's just an easier way of saying what you would have done, right? Give me 5 objects. No, give me 1 object. That's the only thing you've changed, right? But step one, but the most important bigger step is that, wow, okay, now with this collection of objects, I can bring a very, very important power to bear. And that is to say that in this 20 objects in this bag, only 2 of those are actually relevant to the outside world, right? 18 of those objects are not relevant to the outside world. So if I show them all 20 objects, think about it, right? So if someone gave you a big anthology of storybooks, stories, and they told you there is an interesting story in there, and that's from page 15 to 12, 15 to 20, right? And this big book, you're not going to read it, right? It's just going to be hard to find it, and so on and so forth. Better thing is to just say, what, those are the 15 pages, right? Or you can't see the whole book. So like that, an object, so there's 20 objects in here, but only 2 are relevant, okay? Let's not even get them to mess around with the other objects, right? Because, right? So we'll say all these other objects are now invisible to you, right? The student object that you see has only 2 things. It has a student name and a student ID. But don't be misled into thinking those are the only 2 things, because there's a whole lot of other things hiding behind, right, about the student, which is useful for other things, but you cannot see, like the student's address, right? A whole lot of things the student has told, right? Which is only visible to the student, right? And not even to the teacher, not even to the, all these things, right? So everything part of the object, but it presents a facade that is the facade, only the facade that's useful, right? Everything else, not useful. So doesn't have to present. So just like humans, right? So that is the power of object-oriented programming. So struct in C had that, right? And already objects, right? But that wasn't a powerful object. The power of the full object came with saying, taking the full object and then hiding out lots and lots of it, right? So hiding, bringing power, who would have thought, right? It's so counterintuitive, right? And Eric dismissed Steve, and then Steve Jobs couldn't take no for an answer, right? He didn't want the contract, but couldn't take no for an answer, because something you feel is intrinsically true. You just, if you can, right? Yeah, okay. Anyway, enough rambling on about that. So actually, you know what time is it? Well, 8:35, we got a lot of time. We can actually start coding too, right? In fact, what we can do is take a, someone can grab the terminal, and then we can start creating some simple objects, very, very simple objects, yeah, thank you, Mark. And then, an object, and we'll see how to address objects and so on and so forth, right? Lots and lots of different things. Let's start with the C, right? Let's start with C, right? So actually, hey, Mark, let's start with the first, from C, right? Say struct instead of class, struct. And let's also call it student for now, right? And we'll do the player and everything later, right after this initial example. Let's call it student. And then one of the conventions, which I actually like from Java, is to start all the class names with an uppercase letter, right? So it's actually it makes it reading your code a whole lot easier sometimes. Yeah. So then when you declare an object of that type, we'll know, right? So I don't know. Okay, so class student. Yeah. No, you don't have to comment that. Yeah. Oh, declare structure. Yeah. Okay. Now inside the structure, we want a string that's a student name, right? And then you don't have to say student underscore name, because it's already part of the student structure, right? So you can say just string name. Right now you see that now it can be all lowercase, because these are raw members, right? Not structures. Objects have uppercase. Yeah, that's a convention anyway. One of the conventions. So remember previously you said in using namespace and then std : cout and so on and so forth. Yeah. So cout was part of the standard namespace. Yeah. So instead of saying std underscore cout, the namespace can be used to say std : cout. Yes or no? Like that, right? This is when you want to say student's name, you can say student dot name, right? Instead of saying, student underscore name. So, that student is already built in. That's what I'm trying to say. All right. Okay. Now also let's have an ID, which is a long, right? A long ID. Yeah. All right. And then close the structure right there. And in main, declare a student. Declare a student. Say student, my student. Student. No, just a student space, just like integer. right? You say int X, right? You're going to say student S or student STUDENT or something like that. Student S. Yeah, semicolon. Yeah, semicolon. Remember, so does everybody see the similarity between now, what we did now, and then basically int X, double Y, we just say student X, right? We just created a data type of our own. We have two things that always go together. So we lumped them together and gave it a name. Everybody okay with that or not?
Professor, I had a question.
Yeah, Chris.
Since is struct similar to classes, don't we have to put name and ID under public though?
Yes.
Since it's not going to be accessed from main.
Yes, absolutely. You just nailed the, hit the nail on the head. That's exactly right. A struct is basically a class in which everything is public. We haven't talked about private and public and hiding yet. That's why we want to start at the start of a struct and slowly make it up into more things.
Okay.
Yeah. Okay. Great. Thanks for asking that. Right now, in your main. No. Struct is not a public method. Struct is simply a class where everything is public. But don't say that now, because people are going to watch this video and they'll see you building it up step by step, right? So, but that's fine. What you had before was fine. All right. So student S, and then one blank line. Yeah. All right. Now you're going to say S dot name equals mark. Yeah. And you can say no, it has to be within double quotes because it's a string, and also have a space after around the equals, both sides of the equals, because you had it elsewhere. No, you don't. All right, this is up to you. You can choose not to have it everywhere if you want. All right, so and then assign an ID also. You don't have to assign your exact ID. Just assign 1, 2, 3, 4, 5, 6, 7, 8. No, s.id. S.id.
Okay.
Now, the reason we're doing this is because everybody just needs to be comfortable how to address parts of a bag, right? Student is our bag or an object. S, and then dot is how you get inside the bag, to the components, to the parts of the bag. Yes. So is everybody okay with that? Because before we move on, we need to be completely comfortable with that, right? Now, on your next line after, ID, assign 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And then semicolon, and then another blank line. Let's do a cout now. A cout, and then left shift. Within quotes, you say student name equals. Within quotes, you say student name equals. Right? Yeah. And then space. Yeah, exactly. And then do the and yeah. Okay. Then you need an end line. Oh, you did that? Oh, I see. I keep forgetting. You have to. I keep thinking you're in Replete or something. You have to go to your terminal.
Oops. Let's just yeet that and.
But it should have. Oh, it didn't compile then? It didn't even compile?
Well, it didn't overwrite. Wait a minute. Seriously? Huh.
No, you're in the wrong direction. No demos. Where is your source code?
518.21 is right here. So
Okay.
that's interesting.
No. What happens? No, doing it.
Oh, okay. You know what? I put
you compiled the wrong thing.
And then I hit tab. Okay. Wow.
Okay. Yeah, that's fine. We can fix that. All right. All right. Let's go back.
The main doesn't have the parentheses after it.
Oh, thank you, Chris. Okay, main open close parentheses. Yeah. I think that should do it, right?
Looks like it.
All right, great. So is everybody comfortable so far? Because we can't move on until everybody's comfortable. Okay, some of you are and some of you aren't, and you guys need to chime in more. Okay.
I have a
Sounds
question.
good.
Yeah.
Are you okay?
I have a question.
Yeah, sure.
Why do we use struct instead of class?
Oh, struct is historical, right? We've used struct for many decades ago in C. We're going to start at struct, look at some of the shortcomings, and then invent this other thing called a class. We'll start using class in less than a half hour from now. Yeah. Here.
Sir, may I ask what is the function of the student as here? Sorry if I missed that.
Oh, I'm sorry. Chanyi, go on, I'm listening.
I just want to ask what is why do we put the student as here?
Oh, we are defining a data type of we're defining a variable of type student. We told the compiler, instead of asking for a student name and a student ID as two different variables, we'll define a data type of our own. We created a data type called student. And just like give me a double X or integer S or string str, we're saying student S. We created a data type of our own, right? It is our own data type. Yes or no? Everybody okay with that? It takes a while to get around this, okay? You need to understand this completely.
So do these comments look
here
accurate?
I think so.
Okay.
Here, Peter. Okay. I think. All right. I'll put it there. You can have it. Yeah. So, I'm sorry, guys. Go ahead. Keep. Are you waiting for me?
Oh, I was just asking, do these comments look accurate based on what you just said?
Yeah. They're fine. Okay. Well, everything you did was fine. So, and it's going to be in the video too, right? So it doesn't matter. What you described was what you had done before. So yeah, I'm saying what you've written is pretty self-explanatory anyway. So we don't even need the comments, but you can have the comments there if you want. Yeah, that's another thing too, right? I mean, we can also, as you get more comfortable with coding, you'll also start commenting less and coding better. Not, yeah. Anyway, doesn't matter. Is everybody okay with that? You know, I can't move on to the next step until everybody is okay with that. You got to try this thing on your own, experiment, and just a couple of minutes. Make sure you run this through in your head, and if you're happy with that, we'll move on to the next stage where we're going to say the student is let's say we're going to stick some more things in there. Let's say an address field, right? An address field in there. And then hey, not yet, Mark. I just want to make sure that nobody's chiming in, right? And not in chat. Okay, everybody says we're only moving on is if everybody says we're okay to move on, because we have time to cover objects. And I want to make sure everybody's on board before we.
Yeah, I'm good.
Okay. So this makes sense.
Yeah, great.
That's good.
Thank you. Good. All right. So what we're going to try and do now is add one more field, and let's say a string field, address. Yeah, string address. And you don't have to even wait for it. Mark, by the way, in case you're being polite and all, right, you don't have to wait for me to call things out before I type. When I start, you can just type, because most of the time I think you are doing it anyway. Okay? So that's fine. All right. So string address, assign an address, right? And then you can print the address out. And then what we're trying to do here is essentially trying to say, well, hey, the address is really not visible to everybody. It should be private, right? So there we encounter one of the shortcomings of our data type, right? We have cleverly discovered a way to back things together, right? And get them to write together. But unfortunately, some parts of it cannot write with the rest because these, right? So now, we have two options. Yeah, we have two options. One is to say, I'm going to have a struct, which is public, another struct, which I'm not going to show to the others, right? You can have two structures and they'll write in parallel. And again, we're now back to the same problem, right? Saying, oh, I have these bunch of variables that need to write together. I have nested structs. And so this idea is essentially abstracted out and said, inside the struct, we're going to create two classes of variables, right? One class of variables is going to be all private, right? Which means that nobody outside the struct can see it. One class is going to be all public, meaning that everybody can see it. So that's what we're going to try and do. So we're going to change, and that now becomes a class, right? The struct has become a class because we're saying we not only want the ability to make things right together, we also want to make them right together and say one group of them is visible and the other group is not visible. Yes or no? Yes or no so far?
Yes.
Yes.
Okay, great. All right, now let's change struct, the word struct to class. Yeah, and then it's not a semicolon, by the way, it's colon. And I think one of the conventions in indenting it is that the public and private line up with the word class. The keyword, yeah. And then your address is going to be private. Yeah, your address is going to be private because you're not going to expose that to the external world. And colon there. I think, Java programmers tend to do what you did, right? Because they say private for everything, and then that word has to, right? In C++, you can just say private. And also, some people have a blank line after the public section. So that, not after the word public, no, after the public section, to make sure that two separate things, right? And some people don't, that it's just different styles. And I think let's get rid of the second comment. You have two options, two types of structs, yeah, that's all, just useless information that I shared with you, really, if you think about it. Yeah, okay, all right, private string, okay. Yeah, now that's very nice. It looks nice and clean, right? Now, if you compile it, it will not compile, right? It will not compile because the compiler has your back. If the compiler has your back and will tell you, hey, you told me that these three things write together, but then address was private, right? But in your main, you tried to access private, you tried to access address. So that's conflicting. You told me before that private, address should be private. Now you're trying to access it from outside. Okay, I can't let you do both, right? I can't let you have the cake and eat it too. So that's basically what it's saying. Does everybody agree with that so far? Is everybody on the same page? Okay, now we can go on to the next step. Okay, what is the problem? So what's the problem with this approach?
All right, you need the error visible, or would you like the screen through the code visible?
No. What is the problem? What you have is okay. What is the problem with our idea saying that, let's make a string address private, right? Meaning it's not visible outside. It's not visible outside. See, there may be a problem because at some point I may actually want to see the address. Maybe I'm an administrator, or maybe I'm Mark. Maybe I'm Mark, or someone who needs to know Mark's address, right? Maybe the mailman, right? Maybe the mailman says, "What's Mark's address?" Right? And he tries to ask for Mark's address and says, "No, you're not allowed." Bam, right? You can't touch it. Mark's address is private, right? So the mailman can't see your address. You don't get your mail. So, all right. So your address needs to be visible, but only to the people who explicitly ask for it. Yes or no?
Yeah, it looks like in the class declaration, there's no issue. It's really when you
solution, right? Our
do
solution
this here
was very
that it
clever
has
to make
issue.
the three of them right together. That's a very clever solution. There was a flaw. There was a flaw because, and then we said, this thing is going to be hidden, not going to be visible to the outside world, but it's still there, right? Secretly, it's in there. Under the cover, it's there. The man behind the curtains is not going to be. So it was a very clever idea. It's hiding things is a very clever idea, right? This is the thing that really made the power, the power bit you before you saw some of the weaknesses, and you can patch them up. That's what it is, right? Steve Jobs, and he couldn't let go, right? He had to go and convince. So right now I've hidden, but there's the problem, because if it's hidden, how do I change it? How do people even know what it is?
We'll need a method we need a public method. Right?
Yes, thank you. Now, the beauty of C++ is that just like variables, it also allows you to declare functions and attach them to the object. So now here we're going to define a function and attach it to the object. And because the function is attached to the object, it has access to the entire object, including its private members. Yes, does that make sense? Now here, when we do this, it'll all make sense, okay? So under public, because the function has got to be private, public, right? If the function is also private, nobody can read it. Nobody can run it, right? So at least the function has got to be public. So under the public section, right, instead of blank line, because now we're leaving the variables and starting methods. So functions that are attached to objects are called methods. So we're going to create a method here, blank line there, blank line, and say string space get underscore address, right? And then open quote and semicolon, right? Now what we're telling the compiler is that this object has these members, and of these members, address is private, which means outside people cannot get access to it directly. However, this object also has a special kind of method, a special kind of function called a method that I'm going to associate with this. This basically, that's what it is, right? We're declaring all this. Basically, it's just a function in global space that's been associated with some virtual links with this object. That's essentially what's going on, right? So, but syntactic sugar-wise, we're providing it here, a line, and so on. So when we look at it, we see that, oh, it's all in the same place, right? Because if you look even file system, we think that bytes are together, right? Files are together, organized pretty nicely in directories and so on. But if you go and look in the hard disk with a microscope, right, they're not together at all. Your file, which looks, your beautiful story or book, which looks all laid out nicely, your picture, right, next to each other. If you go and look at it, it's not at all like that, right? Some fragment is here, some fragment is there, here, it's scattered all over the place, right? And this is linked together some magically, right? So, the operating system knows that when I get this, I get all of that, in sequence, so I can fill it up. So all of that happens behind the scenes. But what you see is not at all what is actually there. We have just contrived things like that, right? So, so this says there is this address here, and the other people are, sometimes someone might want to see the address. And so if so, I will provide you a function that's going to live there. Just remember that function is now associated with this object and can access all the private members of this object. That's basically what it means. So if you have a public function, which is associated with the object, that function, even though the function is public, can access all of the private members of this object. Yes or no? This is a very subtle concept, right? And this is the reason why, the power of object. This is the object-oriented bug, right? So the power, because it's counterintuitive, right? Who would have thought that hiding things can give you more power? Right? Everybody thinks, you give more, you get more power. But here we're proposing the counterintuitive theory, saying that, well, no, the full thing isn't the whole power is not the power. The whole power is not the real power, right? The hidden power is the real power. So that's really what we're saying, right? And so because it's counterintuitive, it'll take you a while to get used to. Now, you've been using this all along, right? Many people have been using object-oriented programming languages, Python, all these. Many people have been using O for a while. But
Professor?
Yeah, thanks.
Shouldn't we make a set method first for the address before we can get it?
Yes, absolutely. Both. We should get both, right? Thank you for saying that, right? So like the get address, we no, don't declare the function there. Just declare the function, not define the function, right? So put the semicolon after the semicolon after the closing parentheses, and get rid of the braces. We're just saying that there is a public function called this. We haven't defined the function yet. Just like that, define one more function, like Chris said. Copy that line, put it on the next line, triple click. Triple click. All right, enter, and then change the get into a set, right? So we have these two public functions which provide access to address. Now, here's the clever thing here, right? Even though address is now exposed via these gatekeepers, these two are the gatekeepers, right? And these gatekeepers go by the common name getters and setters, right? People call them getters, setters. I think Michael in his notes calls them something else. He calls them accessors and mutators. Yeah, I don't know. It's been a while since I saw the notes. Yeah, I think he calls them accessors and mutators. But I think the more common name these days is getters and setters. One thing gets the value, another thing sets the value. Everybody okay with this so far? Now, if these things didn't exist, if these things didn't exist, no gatekeeper. So address becomes invisible, cannot be seen outside. The only way you can manipulate address is by these two. But the magic of these two is that because these two are functions that we write, right? Not the compiler, not some external party. We have absolute control over what we do with address, right? So if someone in, let's say some, part of the country which uses a 9-digit zip codes, right? Someone, if you receive a call from someone in California, right? You have a get address, you can return a 9-digit zip code, right? Maybe someone in Nebraska, they use 5-digit zip codes, right? So So because your function get address is being called, you have access to a whole bunch of information, and you can reply to that person in the way you best see fit for that particular situation. Yes or no? This is a very subtle and powerful concept, right? Because what we're saying is that because now we have an intermediary, this is the power of middlemen, right? People who help you make money rather than making money themselves. They make more money than you, right? So, right? So this the power of the middleman. You're getting into the position of the middleman via getters and setters, all these public facing functions, because you're saying there is a universe of power on this side. There's a universe of power on this side, right? I'm not going to touch it. I'm going to be the middleman. I can give you whatever you want, right? But the cost of it is that you'll only get it the way that I give it to you, right? So if someone says, you know what, I've done a great deal of work and I have found that there's an incredible amount of the tastiest pizza in coordinates XYZ W in this universe, right? You would never have found that by yourself, but this person told it to you. So he said, well, all right, now I'm going to go there. And because, they can go by themselves. You're going to go, have your fill first. And then whatever you give back to that person is what he gets. Is that, so that's the power of being the intermediary. So we have now the power to get and set the address, which nobody else has. Now, after the class, now we're going to define those two methods. Now, there's two ways of defining these things, and we'll cover both of those today, right? Now, this is called an out-of-line definition. No, in the same file. In the same file. After the class semicolon, right? After on line number 22, hit enter on line 22. Yeah. Now what we're going to do is now you can say comments, right? Comments, out of line definition of the above methods. Okay. Above methods. Okay. Enter.
And Professor, for the set address, shouldn't have taken a string as an argument and return?
Oh, I'm so sorry. Thank you so much, Chris. Okay. Yeah. Oh, yeah. I
or the set address.
Change it. Yeah. It takes a string address as a parameter. String address as a parameter. No, not the getter. The setter. The setter takes a string and sets it. Right. The string address as a parameter. String address, and it returns a bool. Now, some people say setters just set the thing, right? Shouldn't return anything. But there is a reason for returning bool, because what if the setter asks you to set some weird address, which is not true, which is not real?
Yeah, we're going to put return bool.
Yeah,
so you can set address returns a bool.
The set address returns a bool. You have string there on line 16. Yeah, make the string on the returns. It return the return value of set address, the first string. No. The return value. So the return type, not return value. I'm sorry. Return type. The word string on line 16, the first word string. That's what it returns, right?
Oh.
Yeah. That's the value it returns. So you're saying it doesn't return a string anymore, it returns a bool. Now, some people don't make it return void, saying that it doesn't return anything at all. It just sets the value. Now, that's bad practice, except in some cases it makes sense. But usually it's bad practice because a setter is a gated setter. It's a gatekeeper, right? Meaning that it's not going to set any arbitrary value. That's the whole reason for having a setter. If the setter exists because it's a gatekeeper, supposed to filter out bad values. If you send it a bad value, it's not going to set it. Otherwise, you just make this public and allow anyone to set it. Yes? Yes or no? If anyone could set it to any value they want, you don't need a setter. You can just make it public, right? It's like painting a sign on, a billboard on 101. Everybody can see it, but it's only intended for one person, right? Yeah, so I can make it public. The whole point of making it private is because I don't want anyone to come and change it to anything they want. Is everybody in agreement with that so far?
Yes.
Okay, all right. Now we have the setter, which is a gatekeeper. That means the setter is going to have to make some decisions. saying this is okay. I'll set it. This is not okay. I'm not going to set it. Yes or no? Okay, that means the setter is making a decision, one or the other, which means that there is some information that the setter can choose to pass back to the caller. That is bound to be useful. Suppose I tell it an invalid address, it's going to refuse. Then it behooves the setter to tell me, you gave me an invalid address. I didn't set it. Yes? So it should return a bool saying true or false. I succeeded or not.
Like any function.
Yeah. Yes or no?
Yeah. Yeah.
Okay. All right. So that's the reason why the set address is a bool. It returns a bool. And it takes a string parameter because that's the thing it's going to try and set. But before it tries to set it, it's going to do some validation, and say, oh, this is a valid address and so on and so forth. Okay, so we'll do that now. So out of line definitions, let's first define the getter, because the getter is really easy, right? So let's say a string, it returns a string, right? String space. Now, get address is not some random floating method. It is a method that is part of this object, this class, right? So we're going to qualify it just like a namespace. So get address, before the word get address, you're going to say student with capital S, that's the name of this class, double colon, meaning I don't mean any damn get address. I mean the get address that's contained inside of student. That's what this means, right? Student, no, double colon, just like namespace. When you say cout, yeah, when you say std double colon cout, what you're saying is that I don't want any random cout that some programmer might have defined, right? I want the cout that is defined in a standard namespace. That's what you're saying, yes? Just like that here, you're saying, I don't want get address from any damn global function that some random programmer might have, written, and then I've linked into my code. I want the get address that I defined and stuck inside the student bag. You can be as specific as that. And so that is what this means. Is everybody okay with this? This is called an out-of-line definition. You only need to do this if the function you're defining is defined somewhere else, not inside the bag. All right. If it's not defined in the bag, you define it somewhere else, but you say this needs to go in the bag, you put the double colon in front of it. Is that okay? Sometimes you may say, I don't want it to be outside somewhere because it's just one line. I might as well put it inside the bag itself. In that case, you don't need the student double colon qualification. Okay, these are things you'll discover yourself. Okay, so I shouldn't be spending so much time on this. Okay, now you just say return address. Right, so that's all. It's just one line. That's the reason we're going to migrate it into the class and later on. Okay, so it just returns the address. Now, here's a couple of things that we can tips. Right, now this is a valid program, right? No, well, let's do the setter also. Enter. One more enter. Right, we'll do a blank line between methods. Yeah. Now it's not bit set. Is it autocomplete for you?
Yeah, I'm not used to autocomplete.
Was it Notepad? Is Notepad Plus is autocompleting C++ tokens?
Oh yeah, it does it. It's relatively smart.
But where does it load the C++? Where does it load the C++? Did you have to load a package or a module with Notepad?
I haven't touched any packages. It could probably compile from here if they set it up right.
Wow. Okay. All right. Cool. All right. Set address. Right? No. Set address takes a parameter. It takes a parameter. Yes.
All right.
So declare it with the parameter. String space. No, call it ADDR because we also have a variable called address, right? We have a member variable inside class called address, don't we? Yeah. Also, the parameter name on 16, change it to reduce confusion. On line 16, change ADDR address to ADDR. It reduces confusion. Okay, all right, good. Now in set address, what we're going to do is not just going to set any damn address. We're just going to check address to make sure it's not empty. So you're going to say if ADDR double equals, it's got to be within parentheses. All you Python programmers, okay? So parentheses. All right. So yeah, space. Empty string. Double quote. Right? Just return false right there. I'm not going to set an empty address, right? Say whatever. Even if there's some junk there, I don't want you to collaborate. That's what we right? Just return false. Now you don't need the braces even because it's one line, right? And it's a very common line. And because it's a pattern, people just write it in one line to save space.
Goes like Python.
Yeah. All right. Now on the next line, one more enter. Right now you can say we're going to say ADDRESS address. Now address equals ADDR. Equals ADDR, return true. Yeah, now return true. So that's your setter. This is a very simple and it's a very simple set. It's a setter. All it's saying is that if it is blank, return false. If it is not blank, set this internal variable and return true. Now, how do you know it's internal? There's a couple of different ways in which you can say. Someone's something is going bonkers.
Oh, I think what's going on is this is running out of battery.
Oh, was it you, Mark?
It might be.
Yeah. It actually just became, better all of a sudden. What was it? What was running out of battery? Were you running a cart or something out there?
This is some really funky wireless headphones that has a battery life of about an hour.
Wow, and then it started rattling. Okay, all right, great. And false. Yeah, okay. What were we saying? Yeah, address. So we take the address and put it in address, return true. Yeah. So how this address thing is? How do you know why? Yeah, have you declared address in this function? But that's the important thing, right? So that's the thing I should have said, right? You're saying address equals. You say x equals y. When you assign something to a variable, that variable needs to be declared somewhere. So you're using a variable called address in this function. This function you've called set address. This function is called set address, right? Inside that function, you're using a variable called address because you're assigning some value to it. Yes?
Mm-hmm.
But where is the variable? You haven't declared the variable inside the function. But that variable is in the class, right? That variable is in the class. But it's not in the function. So where is that variable coming from? So what that means is that whenever this function is called, make sure there is already an object of type student. Right? So you have to, maybe it's going to be recorded so you can listen to it again if you want, right? What this means is that when this function is, we're telling the compiler, because we prefixed it and qualified it with student colon and so on. Yes, right? We're saying when this function is called, the compiler will make sure that there is already an object of type student. And inside that student, there'll be all these members, name, address, and so on, right? And so any variable referred to by this function, if it it doesn't exist inside the function, look in the object. So meaning that function is basically attached to the object and all the variables in the object become variables of the function automatically. Now, is that clear? So some of you who've been programming in Python and other object-oriented programming might actually find this concept quite straightforward. But there are a whole bunch of you who haven't been doing that, right? So who have just been introduced to programming itself, not even object-oriented. So for you, it will take a little while, couple of days maybe, of having to actively ponder this, right? Not a couple of days meaning, I didn't understand it now, I'll come back to it tomorrow. No, doesn't work, right? Even if you're walking or strolling or, or bike ride or swimming, thinking about it somewhere in the back of your head. Keep thinking and saying, hey, it doesn't make sense. Why do we do that? Why do we do that? And maybe you don't find the answer, come back to it, right? But you got to have that curiosity niggling away at you. And it'll take a couple of days. And then after that, it'll become so straightforward, right? It becomes so straightforward and you won't even see it. Right? It'll become part of the background for you. And I don't, some things need to be part of the background so that you can focus on the more important things. And just like object-oriented programming, right? In OO programming, the power of OO is
Mark.
Yeah, thank you, Chris.
For set address, you forgot the s dot set address because it needs an object to be called.
Oh, duh, right. Thank you.
Oh, thank you.
And same with the get address. And the open and close parentheses.
Wow, you got a lot. This is the point where many C++ programmers says, I'm going back to Java here, okay? Because he's just got a lot of stuff. All right, let's take a look at the program. What happened? What did you fix? Hey, Mark, what did you fix? What did you fix to get rid of all those pages of errors?
Like
you forgot the open and close parentheses.
You didn't do that, and you got a whole lot of errors. Get rid of that again. I just want to see it, right? So taking two minor changes, and then you get like 10 pages of errors. Wow, that is C++ for you. Okay. That is so funny, isn't it? We should make a Reddit clip out of this. It'll become viral immediately, right? That's C++ for you.
Just that.
That is so cool, isn't it? Because, you know, the funny thing is, a lot of people get scared away, but they don't know that all they have to change is like, well, these two little things and everything goes away, right? So big scare, but easy fix, right? People see the big scare, but don't see the easy fix.
So we're looking at some kind of
yeah.
fun
You know, what I do in these cases is that anytime I get like 10 pages of errors like this, I don't even read it. I go straight to my program and run it in my head and say, oh, something must be seriously wrong here. What did I miss? Something obvious, right? So that is usually more productive than anytime you get so much error. I think that's what they're trying to say. The compiler should probably have some intelligence built into it, saying, well, you know, if the amount of error is more than 15 lines, I'm just going to say, you know, take another look at your code, man. All right. That's probably a whole lot more helpful than printing 15 pages of errors. All right. Okay, cool.
Yeah, about that.
All right, cool. Did it all work? Now, if it all works and if everybody's happy with that, we'll go and make some changes to this code to make it more bulletproof. All right. All we're trying to say is to this class, we're trying to bring some of the power of C++ to bear in this program, which started off as a C program, right? We started writing a C program, and then slowly we're bringing more and more C++ power to this by slowly hiding more and more of the power away, right? We started off with a really powerful program, and then we started chipping away and saying, we don't want that, we don't want that, and bringing more and more of the power of C++, right? So if everybody's happy with this, what we'll do is we'll now take this program and make some more changes to make it even more powerful by saying, well, and see, this is what we mean by saying we're going to make the program powerful. What we're saying really is that, you know, people say, oh, by doing this, we make the program more powerful. No, what we're actually, here's my hypothesis, right? The reason we say the program became more powerful by taking information away is because that basically freed up our mind. And our mind is a whole lot more powerful than the computer. Before C++, our really, really powerful mind was grappling with useless nonsense. So C++ came along and said, I'll take care of all the useless nonsense for you. Your mind is too powerful to waste on these silly tasks. Now go away and think about the real thing. Right? And that's the power of C++. And so what we're going to try and do here is really go up to the top of your program and say, let's see, you know, sometimes I keep getting bitten by things that I change inadvertently, right? So some things I just change, and I don't want to change these things. So for example, let's say my getter, the get function, it is just supposed to return the value. It's not supposed to go and fiddle around with it. What if someone wrote the getter? What if I, in my deluded mind, wrote a getter, which instead of just returning the value, went and changed the value? Then really that's a bad getter. So let me make sure that I don't do something stupid like that. How do I make sure that I don't do something stupid like, so in other words, we're trying to use the power of C++ to guard against our own errors so that we don't have to be mindful of those errors anymore, right? So we're trying to free your mind, right? Like the song. So what we want to do is get address. Let's tell the compiler that this is a constant method. I'm never intending to change address from in this method or any method that this method calls. That's the power, right? So now the compiler knows. Now you tag this before the curly brace, on line 23. Yeah, a space, just like a function, right? You tag the function const, right? You can tag methods const, right? So no, actually, you never tag the function const. You only met. So const goes elsewhere in function. Forget I said that. Okay, right? Space, space. Yeah, put a const keyword there. const, and usually people have a space after the const because it's a keyword on its own. Right? What that means is a signal to the compiler, saying that make sure that I don't accidentally shoot myself in the foot by changing something in address or changing anything in the object, because this getter is supposed to be a pure getter, meaning it does not change the object. It is a const method. So you can signal, right? You can say signal. And I don't know if you can do this in Java. There's something called final. It's been such a long time. But you know, it's some languages let you do that. You can say that here's a method. No, that's in Java. There's no final. Const is basically a signal to the compiler saying this method is const. Now, you may think that, well, why do I need to do that? Because it's so simple. You know, getter is one line. I can see that it's not changing anything, right? But things will very quickly get out of hand. Pretty soon, you may be creating objects. This is a very simple student object, right? Pretty soon, you may be creating an object in which you have a method which is supposed to be const, but in that method, you may be calling 5 other methods. How do you know if those methods are const or not? Right? You know you're not changing the object, but you're calling some guy, some contractor, that might go and change the object. So you need to make sure before you call a contractor, you need to make sure that's a contractor that has gone through the right schools and knows not to touch const objects. So you need to only call contractors that are tagged const. And those contractors need to call other contractors that are tagged. They can call. So you can see how very quickly how exponentially hairy this problem becomes. Yes. When you tag something with const and you have to manually track it down the compilation tree, you can see how hard it'll become. Now that one word on the line makes the compiler do it for you. Right? Now you don't see the power of it, right? Because it's just one line and one function and one method. But when you write methods that call other methods, you'll see how the compiler basically has your back. It'll make sure that no method called anywhere downstream from here, right? Million calls down. None of those guys can change the object. And the compiler will make sure that happens for you. This is really, really cool, isn't it? Right? Now, with that reassurance, a big chunk of your mind can now be free. So that's one of the one of the powers that we brought to bear and say, hey, oh, I'm sorry, you've been experimenting. Right.
I was trying to get the compile. If I had this const, it just doesn't.
Oh, no. You have the reason you have the errors happen is because you said it's a const in the definition, but not in the declaration.
You have to put const after the string in line 15.
On line 15, yeah. No. That says it returns a const. No, the const needs to go on the other side. That means it doesn't change the object. Yeah.
Yep.
Yeah. And thank you for experimenting with like that, because what Mark was doing right now, as we were talking, is trying all these different things out, and that is the best way to get to grips with all these things. Because
also I like to execute my program after just about every line of code.
Yeah. I think we should all get into that habit, because compilation is so easy and cheap these days. We should really not defer it to some grand event downstream. It should be incremental. Incremental builds. That's the flavor of the season. Right, incremental compilation, right? And in fact, many Eclipse, right? I'm pretty sure doesn't happen in Xcode, but Eclipse in Java, I remember a long time ago, I code every time I hit save, it compiles. Bam, bam, bam. Every time I save something, it compiles. And incremental compilation, right? But of course, it's only going to bytecode. It doesn't even do optimization, I guess, or maybe it does some kind of optimization. Anyway. Yeah, okay, is everybody okay on board so far? If you are, then we can go on to the next step. Well, one more thing we want to do. What we'll do is now we'll say, because this getter is so trivial, this is what is called a trivial method. A trivial method, rough thumb rule I always follow, trivial method, one line, okay? If it is one line, exactly one line, I call it trivial. Even if it's 2 lines, right? If it is, sometimes an if statement, if return immediately, that can be made into one line, okay? Then I call it trivial. If it's just return something, trivial. Anything more than that, I say it's not trivial. So what I do is anything that's trivial, according to the definition that I just gave, I move it into inline code. Inline meaning, well, you know what? This, no. Get rid of the line. Thank you. All right. Okay, so that function on line 25, why it doesn't really deserve a function body of its own. I'll just take it and put it inside the object itself because it's so trivial. So what I can do is, let's leave that there. We're going to get rid of it. Go inside the function, get address const, right? After the const, you got the semicolon, right? Instead of the semicolon, have a space and start the body right there. That's called an inline definition, right? Space and a brace. A space and brace, yeah, one line. Oh, if you want. Oh, you can do it on 2 lines. That's fine. Yeah. Yeah, you can do it on 2 lines like you wanted to do before, right? Return.
Like that.
Return address right there. Inside braces, you say return address. No. The const. It still needs the open close. Oh no, hang on. No, I can't see clear. Hang on. I got to increase the window size, right? I'm going to lose some of you. 1 sec. Oh yeah, curly braces. Yeah, have a space before the brace because it's a function body. And then you don't need a semicolon after the brace because it's closing the brace, right? And then sometimes people also have a space after the brace and space before the closing brace, but that's okay. All right, so that's it. Hey, clean up the code. Your code was, your comments were all messed up. These functions access and modify the private variables, right? Indent the comment, the comment on line 14. Push the comment in by 4 spaces on line 14. On line 14. All right, and then on line that is getter accessor with const, accessor with const. Get rid of that, slash accessor. It's too long, right? Const, make that a const getter. I don't know. Get rid of the comment. I don't know. It's all in the, and also get rid of the comment saying scatter mutator because it's a set address. Because then we can, inline definition is better. Yeah, and then get rid of the comment. Yeah. Okay. Hiding things give you more. All right, cool. All right, now string address, return address. Okay, now that is what is called an inline definition. Is everybody okay with that? This is how you can take a definition from outside and put it inside. When you put it inside, you can get rid of the qualifier, the class qualifier. You can get rid of it. Let's take a look at the code again, see if there's anything more we can do to it. Does it work? Does it work? It should work, right? Great. Let's see if we can do something else. Const return address. All right, yeah. Set address takes a string, right? Now in this case, it's a string. Now what happens if it's a really complex object? If it's a really complex object, right? And it's like 15 million bytes big, right? Then you don't want to pass the whole object by copy. In this case, a string, well, it does some intelligent things behind the screen, even if you pass it by copy, right? So what we want to do is always pass by reference, just like Mark just did, right? So we want to make sure that the parameter is always passed by reference, okay? Now,
I don't think
you guys, yeah, good. I'm very happy you're getting bitten by this, right? Because you got to run into this many times, and oh, I changed one place and not the other, okay? What happened? What does it say? Okay, non-const L value reference. All right, let's go back. Oh, I see. Because it's a string. All right. Here's what you can do. No. That 1, 2, 3 thing. Make that string. Cast that to a string. Right. Say string. No, before the double quote. Say before the double quote. Say string, and then open parentheses, and then close the parentheses after the closing quote. I'm just shooting in the dark. Not shooting in the dark, but I'm guessing. That's not it. What is? Oh, cannot bind non-const L value reference or type string reference. All right, let's go back. Let me read the code again. All right. So where's the that's a, all right. So yeah, let's put it back to string 1 to 3.
Okay.
After student S, this is an experiment, right? I'm just trying an experiment, as you can tell, right? After student S, create a string string str, yeah, equals 1, 2, 3, 1, 3, and then pass that. Did you pass that? Did that work?
Yeah, I need to, I just can't see it when it's at the top. Oh yeah,
Great,
looks like that works.
That should work, yes?
Mhm.
Okay, great. So what it means is that you can't pass this constant string. In C++, if you have a thing with double quotes, it converts it to a constant string, right? It doesn't convert it to a mutable string. And let's not get into the detail differences right now. What we did here was simply create a string object, which is a local variable right up there, str, the string object. Now that we have an object, a proper string object, not a anonymous thing created by the compiler, right? We can pass that as a reference. Now we pass the actual thing, right? How can we improve this? How can we improve this so that this object that we pass, the actual object that we pass, is that okay? Can we improve this code? What is the risk? What is the risk here? What time is it, by the way? 9:29.
9:30.
Yeah, what
The
is the risk?
risk is that you feed it a non-string, maybe?
No, I could feed it a string. Well, forget about string, okay? Let's forget about string. Imagine it's an object, some other object, okay? Imagine it's some other object. Or even string. Let's just keep it a string. Keep it a string. Yeah, I pass it. What is the risk? What is the risk here if I pass? Think about it. Take some time. Think about it, and it's important, right? How can we make it? It'll work, right? As we just saw, it worked. But
if we don't set a valid argument, it's not going to set anything. Right?
We still do that. We still do that. If address is blank, it's not going to do anything. That's fine. It's not a risk. But there is a risk to the designer of this program. How can they make it more bulletproof against themselves? I'm not talking about someone else fiddling with your code. I'm saying, how can you make your own life easier by doing something here, right? How can you make
you can feed it an empty string and it doesn't have a compiler issue.
Yeah, it's fine. You can pass it an empty string. It'll just return false. In fact, when you say set address, say bool p equals set address, s, bool. On the same line. Oh, actually hit enter, enter. Yeah, okay. On line, no, not there. On line 38, No, you have a blank line after the declarations before the program starts. Yeah. No, on the same line, on line 37, beginning of line 37, beginning of line 37. At the beginning of line 37, yeah. Say bool p equals p. People usually use p for preposition, right? P, or b equals. All right. On the next line, you can say set return b, right? So, and obviously b will be 1 or 0. Think about it, right? In C++, it's really sugar candy, sugar coating over C, right? It's just 1 or 0. It won't be true or false.
You don't want to see out this?
No. Yeah, see out, probably. See out and say and tag it saying set return. The setter return or the set return, and then left shift B. Now here's the thing, right? If you left shift B, it's going to print 1 or 0, which you don't really want to see. No. All right, run it. Yeah, it's going to return 1 or 0. And what we want to do is not 1 and 0, because 1 and 0 doesn't look like C++, right? So let's go back to the program. Let's put a ternary operator right there where you have B. Yeah, all these things we're doing, we really don't have to do, but really it's good practice, right? Because you can see how we can take a simple program and change these things, right? B, and because it's a Boolean, you can say B question mark, B, put the whole thing with, B question mark, space, right? If it is true, you want to say TRUE within quotes. No, within quotes. If it is false, because it's a ternary operator, remember, okay? And then after and then space colon. No, not colon, and then false. And you can do anything there, right? It doesn't have to be true, false. It can be Y, and yes, no. No, not ready yet. No, now that ternary operator, that expression returns a string. Yes, that whole expression returns a string, right? So put that expression inside parentheses, because otherwise the operator can't tell. Yeah. No, you only had one side. Oh, you had both. Yeah. Is that okay? All right, great. Now you can, you knock yourself out later by playing around with this. Now, obviously, if you try and set an empty string, it should return false. Right? So I set an empty string, it should return false. No. So I set an empty string. So leave the C out there and set empty string there. It'll return false.
Oh. And it didn't work.
Yeah. See, I'm pretty sure. There you go. Right now, you know what the setter did. It returned false when you set an empty. Right now, so you can put back your address. So what is the risk? What is the risk of this? Now here, let's do one thing, right? Setter return true. Now after your after line 42, hit enter, right? And say C out changing address, right? C out and say changing address, right? And then new line after that, and use a setter to set a different address. Yeah, new line. You don't need a colon there. You can remove the colon space after changing address. We're not gonna, right? Now on the next line, use a setter, s.set address, and set a different address, oh, I see. You need another str2. str2 says Kiro create an str2 to something else. I think you're running out of battery again with these headphones. All right. Okay.
No, I'm just bumping into the power cord.
Yeah, enter. Yeah, always helps to have a declaration part and then a body part. Okay. All right. Now set address to your str2. Now print your address again, right? So, triple click on 44 and paste it again. No, just triple click on 44 and paste it again. Right. Now, if you run it, right? You run it, you get maple. All right. Now let's do something really crazy. Okay. In our setter, let's do something really crazy, right? So because you're passing by reference. Yes. Okay. Now in your setter, go into your setter. In your setter code, right? All right, setter code, address of on line 28 on go to the end of 27 and hit enter. Oh, actually, yeah, that's fine. Leave it there. Go to the end of 29 and hit enter.
29.
Yeah, 29. No, before the return. Yeah. Now let's say address of zero, off zero, square brackets, because you know zero comes into the string, right? Address of 0 equals x, uppercase X within quotes, some character, anything you want, right? No, within double quote, within single quotes. It's just, characters need to be in single quotes, strings need to be in double quotes. Yeah. Okay. Now let's run it again. Yeah. So now you see what the risk is. So how can we improve this program? By saying, because already Mark improved it by saying, well, let's pass a reference, because big objects don't have to be copied. Only the reference to it need to go, right? Now, how can we improve the program even more so that we don't do inadvertently, we don't do crazy things like change something that was passed to us as a parameter in the setter. Come on, take a stab. How can we hint to the compiler? To make our lives easier?
Can we throw in a const?
No, you can't make it a const, because a setter cannot be a const, right? A setter has to change the object. Yeah, a setter has to change the object. So how can you make it better? It's a puzzle for you, right? It's a mini puzzle, mini quest for CS2A. How can you make that even better? How can you make the compiler have even more of your back?
I have no idea.
No, take a guess. I don't know. I don't believe that nobody has no idea, right? I'm pretty sure everybody has some idea, but the important thing is to take a stab.
Branching statement, just to look at the.
What's going on? What's the risk? Let's just say what is the problem? What happened right now?
Well, this right here changed the first letter of your output.
No, they changed the first, but is the change in the first letter of the output supposed to happen? No, right? So something happened in the setter that is not supposed to happen. What happened in the setter that wasn't supposed to happen? What did we accidentally do in the setter that we're not supposed to have done? And the compiler didn't warn us, and the compiler just gave us a clean bill of health. Yeah, because you compiled it with the G++ and gave you a clean bill of health, right? It didn't say anything was a problem.
Yeah, we did not have compiler issues.
No compiler issues. But when you ran it, it didn't give you the expected output. It gave you a corrupted address. So something happened there, which the compiler should have warned us about, and it didn't warn us. Why didn't it warn us?
That's a logic issue.
It didn't warn us because we didn't tell the compiler something very important. What didn't we tell the compiler that was very important to us?
Like we didn't give it flags for warnings.
No, Nothing could, what happened? What happened in the setter that was not supposed to have happened?
Oh, it actually changed the reference string.
Is everybody okay with that? Everybody follow what Mark just said? Everybody? Speaker Run, Maxim,
Oh.
Chaya, all of you guys,
Yeah,
I can see now.
It
Jacqueline.
shouldn't be doing that.
So you shouldn't be doing that, right? But yeah, but you did. No, wait. You shouldn't be doing that. That's fine. So we shouldn't be doing that. But we did that. We changed the parameter that was passed by reference, but the compiler didn't want us. So what good is this 2-bit compiler that didn't want us when I was doing something really bad? That's because we didn't tell the compiler how to help us. We didn't tell us what we were trying to do. And what we're trying to do is we want to change address, but address should not be changed beyond that, right? So the parameter itself should not change, right? So what we want to do is that address that's being passed in. Oh, I'm sorry. I'm so sorry. We're talking about completely. I guess we hopefully someone should go into this YouTube video and make a comment when we started talking about this, because what I should have been talking about was this change. We shouldn't have made to address. We should have made to ADDR. Take that line, triple click on that line, ADDR, triple click on the line, triple click on the line. I'm so sorry, guys. All right, please rewind this video or at least make a mark saying, the last five minutes, maybe there's a minor issue, right? Did you ADDR? Yeah, thank you. Let me also increase the size. I'm going to lose some of you again. Okay, fine. Okay. Can you go back to the code again, please? I'm sorry, I didn't.
Well, I just want to point out that actually doesn't change the output.
Yeah. No, yeah. Obviously, of course it wouldn't, right? So ADDR. No, after you do the change, assign to address. You assign to address and then change the parameter. No. Assign to the parameter and then change the address, right? So take line 28 and put it after line 29. Yeah, okay. Or either way, that's fine. No, but put and then blank line before that would be that's fine. Right now, you'll still have the error. Do you have the error? Does it say X123 Maple? Right, X23. So you have the error, and the compiler didn't warn us. And that's because if you go back to the code, we see that we're doing something bad. We're changing address, which is passed in as a reference parameter, and then using that to set the address. But we shouldn't really be changing anything, right? That guy told us paint the car blue, right? And you can't say before I pass this work order onto the manager, I know that we don't have any blue paint, so let me change the blue into a purple and then give it to my manager. So the manager will say paint it purple, right? So that is not a good. That's not a good workhorse function, is it? If it changes the order coming in and passes it to the compiler, that's not a good workhorse function, right? So we can make it better by saying, be a good function and say that what's coming in cannot be changed because it's coming by reference. So does everybody see how you can improve the function by changing the one line on the setter declaration saying that whatever comes in cannot be touched? So it's const string reference. No, so that's the only thing with C++, right? The function const, the method const goes on this side, but the type const goes on this side. So with this one, the const needs to go const string address of.
It didn't like that.
Now it won't compile. The compiler will have you back and say, I can't compile this for you because you're trying to change something that's const. Now try and compile it, it'll tell you, right? If you compile this, the compiler will tell you that, where does it say? Yeah, there you go, right? It says right there that, it should show you the exact message.
Hold on, let me just clear the screen.
Yeah, clean it, compile again. Okay, just one second.
Why is this? There
we go. Candidate is. Oh, I see. You didn't change it in the declaration. You just changed the body. That's the same bug as we've run into 5 times, right? You have to change it both places. All right. Okay. Now you see the compiler back message, right? The compiler's got you back saying, hey, in your method, you're trying to change something that you told me, to watch out for, right? So do you see how beautiful this is, right? So this is real freedom. Right? People say, freedom is having all the mundane things taken care of so that you can focus on what's really important. And the power of object orientedness gets you there because it takes care of all the mundane things. As long as you tell the compiler, you got to tell the compiler, these are all mundane things I don't want to track, right? You keep track of it. So I can focus on the algorithm, because that's how we can go on to solve these big problems, right? So the other thing is, before you go on to enroll in 2B and 2C, please don't read the Reddits, right? So please don't read the subreddits, because I think that a lot of students just, or maybe even after you enroll, right, in the first couple of weeks, I think a lot of students in 2C basically gave up on 2C after reading the later subreddit posts. They're saying, oh, this is so hard, I struggled, and so on. And they are struggling with the earlier ones. And they think, well, if I'm already struggling with the earlier ones, there's no way I can master those, right? So, and that's the problem, is only because you went and read ahead and looked at all those things, right? For them, so hard is exactly as hard as this is to you, right? As by the time you get there, that will be just as hard as this is now, right? It's not going to be more. And so, and don't do that. And so just staying one step at a time like this is perfectly fine, right? And pretty soon, right? By fall, no, don't do in summer. Don't do 2B, maybe, I don't know if you're really pressed for that. But if you do 2B in fall and then 2C in winter with me, you can compare, right? Your own 2C with these videos that you are doing right now in class, and see the difference, right? And then you'll see, wow, this thing, I just use it unthinkingly now and not even think about it, right? It's all invisible. But like 3 quarters ago, I was coding on screen, and this, I need to be talked through this, and it'll all seem like a completely different world for you, I think, right? So it'll be fun. But I think it's time, isn't it?
So
Oh,
I have a question.
Mhm.
So what we are trying to do here, since we apply the end sign in the ADDR, so we expect the compiler to give us an output that would not be changed. That would be exactly the same as the original
No,
information.
const. The ampersand does not mean that. Const
But
means,
it's passing the reference.
yeah, ampersand means just means it passes the original, not a copy. Passes the original string.
Mhm.
That's what the ampersand means.
So
The ampersand has nothing to do with const, not changeable.
also const is non-changeable. It's not constant. Okay,
Const.
got it.
So read only, right?
Read only means const, yeah.
I see. Thank you.
Is everything okay so far? This is basically just a very light intro to objects. And it was quite late, wasn't it? Was it a reasonably late lecture today? Yeah.
If I was able to code it, it was pretty late. So I didn't know much about methods before this.
Yeah, so that's basically, you've written most of, the essential parts really is creating a class, right? Knowing what a class is, how it's different from a structure, and what opacity brings you, right? Versus transparency. Opacity versus transparency. That's really the hardest thing to get. You could be programming for years, and not understanding the power of opacity is where most programmers, even though they're brilliant programmers, right? Many brilliant programmers waste all their brilliant cycles on non-brilliant things. And that's why they don't do brilliant things, right? So if brilliant programmers can have the non-brilliant things taken care of, they can focus on what would actually, make their brilliance shine. Yeah, and it'll take a while. It'll take a while. I don't know. Yeah, that's why I keep, I say this even in social media and other places where people say, can you learn this in 21 days or 3 months or 1 quarter or 2 quarters? It's never, ever like that. I can promise you, right? And I would be very, very surprised to see a counterexample that in order to truly master programming, it is impossible. Even if you're a prodigy, well, maybe if you're a prodigy, because I never know what it's like, right? But it's not possible. You have to keep on programming for a while before it actually hits you, right? It's like, you can keep playing. When my daughter was playing the piano, right? Or learning the piano, I used to look at where she was.
10 minutes.
Yeah.
Oh, sorry, forgot.
Yeah.
Yeah, someone
Anyway,
called me
yeah,
on your side.
I was thinking of where every time she was struggling, I noticed this correlation that she was always getting ahead of herself, basically overstepping the metronome, right? So getting out of the groove or not in the beat. So if you're not out in the beat, then you start panicking, saying, oh my gosh, am I in step? Is the next note right? And then you start thinking, right? But if you're in step with the metronome is already tuned to give you enough breathing, right? And you say, I have time. I only have to press one key per beat, right? And you get into the groove, then I think she just sails through all the songs. But then when she was learning, right? But before getting into the groove, the songs were a struggle because she was always fighting both being in step as well as remembering the tune. And I think it's the same with programming too, right? Taking it one step at a time and making sure that everything is okay and breathing, right? So in fact, when you do acting at Foothill, Melissa, who teaches it, spends the entire first 10 minutes of every class just forcing you to stand and breathe, right? And that's all you do, because many people just forget to breathe. And they deliver their dialogues incorrectly and they breathe at the wrong times, right? So just learning to control your breathing is very, very important in any theatrical performance, right? So if I am, for example, Indian music, right? So these focus a great deal on just developing the rhythm of breathing, right? And getting your notes on the breaths rather than at random places, right? Then you can focus on the melody and not on getting the right thing in the right place. You can't focus on two things at the same time. And so, yeah, I don't know where that relates to programming, but that's basically it, right? So, and don't worry that you're not getting, it'll take time, but just keeping at it every day will make it all transparent and opaque because you don't see it. You don't see it because it's transparent, right? And I think that will be absolutely awesome. I think we're at time now. If you don't have any questions, I can let you go. If you have any questions, I'm happy to talk about that. If you want to do more things to this program and experiment while I'm looking, you want your own time for the next 20 minutes or 5 or 10 minutes. If you want me to switch off the video, I'll be hanging around here, right? I'm happy to do you like that?
Do you think writing things in an object-oriented fashion will impact our score on the quests from 5 on?
Well, you have to, right? I mean, from quest 6 onwards, you're going to be creating objects.
Okay.
Yeah, but if you're asking whether any old program you write, if you write it object-oriented way, it will improve your program. Is that what you're asking? Not quests. Are you talking about any old program or?
Well, specifically the like score for the quests, but yeah.
If you do what the spec says, you're fine as long as it's. I don't believe object-oriented is explicitly enforced in many cases, right? But otherwise, I think it's. Hang on. Oh, sneeze! That almost came. All right. Yeah. That's basically it. Yeah, you can. Quests don't need you to be object-oriented unless it actually explicitly specifies. If that's what you mean. Yeah, is that okay? Do you guys want me to basically step away? I can switch off the camera and mute the microphone and step away, and you guys can talk, right? Or you can play around with the code. You can play around with more code if you want, right? And if you want me to come by, just call out my name. Yeah, is that okay? And you guys can just disappear, right? And in 5 or 10 minutes, I'll come back, and if there's nobody in here, I'll stop the video, and then I'll edit out the last 5 minutes of silence and then post it on YouTube. Is that okay with you guys? Yes or no?
Yeah, I had a quick question.
Yeah, sure.
Did you say don't take your 2B class this summer and wait till fall?
Yeah, I think really I shouldn't be offering any courses in summer. Maybe next year onwards. Because 2A is okay to take in summer because you can finish 2A in 6 weeks, right? And still enjoy the full thing. But I think 2B, you cannot enjoy it in 6 weeks. It'll take you at least 12, I think. Oh. Wow, excuse me. Thank you. Wow, a long time in coming, but certainly worth it, I guess. All right, yeah, 2B, you'll be rushing through your quests. You won't have enough time to appreciate what you're doing. That's especially noteworthy. You can get the points, you can get the quests, you can move on. You can get the trophies, move on to higher number quests, and even get your degree and grade and things like that. But usually,
I was thinking of just taking discrete math and 2B, but
yeah, you can take those.
It's only 6 weeks now. I'm only going to take one of those.
Yeah, take discrete math. Yeah, I'm pretty sure Patrick is teaching discrete math in summer. Patrick Morris.
Oh, okay.
He usually teaches discrete math, and you can check with him. Actually, I don't know if it's too much for summer, but he'll tell you. And but do some of the prep courses if you want, but just program a lot in summer on your own. Just do lead code, lots and lots of lead code, lots of random programs. Do your own projects, or if you want, do a Zoom session with me. I can walk you through taking some of these games and turning them into JavaScript games on the cloud, in the cloud. Right? Do things like that. Just keep yourself mentally occupied and engaged. And then 12 weeks of fall is the best time to take to be winter, any 12-week period. And I think it actually works out nicely because people who enroll in 2A in fall can do 2B in winter and 2C in spring. So 3 months, right? Three months each, and you're done with the series. Unless you need some breathing time between the courses. I don't think so, right? Because it's 12 weeks, you probably already get some spring break and summer break, or winter break. Yeah, that's what I would recommend. And there's a great selection. And I don't know if the questioning style appeals to you, or this style of learning, right? Informal structure class, and people are coding on code, because we do offer a lot of classes at Foothill that are also taught in the traditional way. So even in computer science, we have a lot of great instructors teaching with material in a style that many people are used to. So that's worth considering, right? Whether it's online or whatever it is, you should probably. But yeah, I would absolutely love to see you all again, one more time. Right, 2B, 2C, it'll be fun. Especially since now you have history to refer back to, right? When you're doing 2B and 2C, you can also tell students, hey, you know what? Back in 2A when we were working on this, and same guys, it'll be fun. Just like going to school in the classmates. Yeah. All right. Can I step away? And then you guys can step leave as you see fit. And I'll be around, and you can call out to me if you need it, if you have any questions. Yes. Thank you all for humoring me and letting me ramble on and on. I'll leave you to play with the rest of the code, and then see you guys on Thursday. Yeah. Bye.
I'm gonna throw this on Reddit. When this is done, does anyone got any discussion or stuff they want to talk about related to the code, maybe? Is anyone?
Thank you. Bye.